So sine law is great and all, but you need to have something that is opposite to something else. We need to have an angle and a side that are opposite each other in order for the sine law to work. Now if you don't have that, then you're stuck with the cosine law. And the cosine law is a little bit more difficult. Okay, so it's a lot more difficult to set up, but the sine law is pretty basic. So cosine law, you guys can handle. You've done more than this in physics before, so let's get going. So here we have a triangle with two sides and an angle, but nothing's opposite. So we can't use the sine law. What we do instead is incorporate this little pattern. And let's go with what we're looking for is that other side over there. Now typically we use big A to show the angle and little a to show the side that's opposite of that angle. So that's why they match. So I could make this formula, instead of using theta, I could make it big A to show that in the formula, this angle and this side have to be opposite each other in order for the formula to work. The rest of it's just details. Now, to show you how this goes together, well, I think I'm going to start by slightly rearranging the formula just a teeny bit right to start with, because this is a squared. And so I can just write A equals the square root of all of that. Now, if you're handy with your calculator, you can probably figure out how to put all of that into one simple calculation. Simple. But if you're not so keen on that, then you can do it in little steps. For this one, I'm going to break it down into little steps just to show you how everything goes together. So I'm going to start off by just going A equals, and I'll write the square root because I'm going to need lots of space. And it doesn't really matter which order I put these two sides in as far as B and C goes. It's just saying that they're the two sides that aren't opposite to the angle. So I'm going to go 15 squared, probably just keep this one handy, plus 19 squared minus 2 times 15 times 19 times cos of the angle, which is 44 in this case. Now, I'm going to caution you that you need to make sure your calculator is in degrees, because otherwise you'll get a number that's much too small, and that's because you're in radians. I don't know what happens if you're in grads. No idea. Okay, so we've got it set up now. We can solve that. 15 squared, I think, is 225 if I'm not mistaken. But you probably won't have those memorized because you're not a math teacher. But let's just check and make sure that I'm not going to embarrass myself here. 15 squared equals 225. Yay! So now I got my 225. Then I go 19 squared equals 361 minus, and here's where it gets a little bit trickier with your calculator. So what I would probably do is go cosine 44 and then multiply these guys back. And once in a while you're going to have a cosine value that has a negative, so watch out for that because it'll change this sign. Times 19 times 15 times 2. So I got 410.02. You don't want to round off too much, but you know, within reason. So now I've got these three under the root sign, and it's a little simpler to go forward with. I'm going to just cheat and multiply that by -1. I have a negative value. Plus 361 plus 225. So the whole thing is going to be the square root of 175.98. Now, if somehow this was bigger than this, then you're going to end up with a negative number under here in an unsolvable triangle. It's unlikely that they're going to give you something like that because they're expecting you to solve the triangle. So you might want to look at this and ask yourself if you didn't miss something there. If your angle is bigger than 90 degrees, cosine's going to be negative, and that's going to muck up your equation, so make sure that you keep that figured in. Okay. Second function square root, second function answer. Whoops, what did I just touch? Alright, whatever. Second function square root, I'm going to write this in because I just did something funky. So it's 13.27. And I'm going to look at my triangle, and assuming that it's relatively to scale, then this looks like a shorter side than these ones, but it's in the ballpark. So 13.27 for that makes sense. I'm going to call that good.